The blower door air tightness testing system has been an important component of quality control and protection in buildings for more than 15 years. The reversible fan generates pressurization or depressurization and allows the user to determine and discover leaky areas in any building. The calibrated flow rings of the fan allow accurate measurements for all testing requirements. Standard measurements in new buildings to document compliance with the energy saving decree, especially for the small airflow needed in passive houses, and additional quality management for ventilation systems, in big multi-level administrative or office buildings, in old buildings as an important part of modern energy advice. The blower door test can be easily automated using the DG700 pressure gauge. The precise pressure gauges also allow inspection of ventilation systems. Along with the blower door, other diagnostic tools such as an anemometer, fog generator or smoke pen, and an infrared camera can be used to locate and document air leakage sites. The blower door's lightweight and compact construction, along with its easy handling, allows precise air tightness measurements at any time. The blower door is mounted in an exterior doorway. The fan exhausts air out of the building and generates a depressurization of 50 pascals. During the pressurization test, outside air is continuously drawn into the building through holes and penetrations the building's envelope, making these leaks easy to locate. The specific building tightness measurement is the air change rate N50. The blower door is installed in an exterior doorway on the ground floor. First, the clear tubing used to measure the outside pressure is placed down. The aluminium frame is easily assembled by connecting the vertical and horizontal frame pieces. The frame is adjusted to roughly fit the door jamb. At first, a narrow gap should be left between door jamb and blower door frame. The frame pieces are tightened with the knobs. Now the nylon panel is attached to the assembled frame with Velcro fasteners. Insert the nylon-covered frame back into the doorway. Loosen the knobs one after another and readjust the frame so that it presses against the door jamb. Retighten the knobs and then engage the cam levers on each frame piece. The cam levers provide the final tightening against the door jamb. Two crossbars are now installed in the middle of the frame and are tightened. The clear outside pressure tubing is now attached to the bottom pressure tab on the outside of the nylon panel. The fan is placed into the large hole in the nylon panel. The Velcro fastener on the lower crossbar holds the fan safely in the frame. The gauge mounting board with fan speed controller and DG700 gauge is attached to the upper crossbar using the clamp on the back of the mounting board. The speed controller is now connected to the fan and plugged into a power outlet. To correctly record pressure differences, coded tubing is connected to the gauge according to the marks on the gauge faceplate. The red tubing used to measure fan airflow is connected to the fan, and the blue tubing is fixed at the fan's tape. The green tubing used to measure the outside pressure is attached to the inside of the bottom pressure tab located in the right-hand corner of the nylon panel. The blower door's computerized fan control system provides convenience and security in all testing applications. The easy-to-use Tactile Express control software speeds up the testing process, reduces operator errors, and ensures that tests are conducted the same way every time. Before you start looking for air leaks, be sure that all windows in the building are closed. The blower door is first used to generate a constant pressure difference of -50 pascals across the building's envelope. This provides a quick estimate of the building tightness level and helps to find air leakage sites by drawing outside air into the building. Tactile Express displays the current air change rate estimate. With the blower door running, the building's envelope is now inspected for air leaks. Air leaks can often be found using your hand. However, it makes good sense to use technical instruments to detect and document the leaks. The anemometer precisely measures air flows and its speed. Leaks can be easily detected and precisely documented. One way to visualize air flows is to use a smoke pen. The movement of smoke allows the leak sites to be easily located and understood. A non-electric fog generator is another good tool for visualizing air leaks. Air leaks become clearly visible as the fog is drawn into the building from the outside. The ideal technique for leak detection is to use infrared thermography along with a blower door. The infrared images make the consequences of air leaks easy to understand, even for laymen. Leak detection can even be done in buildings with high ceilings without a ladder or scaffolding. In the winter, air leaks can result in significant damage to buildings by allowing moist air to get inside the insulation. This can lead to condensation and rot. Sealing leaks and avoiding even greater damage is only possible after finding the important leakage sites. Thus, the blower door test provides greater protection from damage caused by uncontrolled air leakage. After the leak detection is completed, a more detailed measurement of building air tightness is performed. The standard air tightness test procedure automatically measures the exact values of the air change rate N50. The TechTide Express program provides step-by-step instructions on how to perform the air tightness test according to the prescribed standard. The test is controlled from test graph screen, which displays the measurement data as it is collected. The program provides easy-to-understand on-screen instructions which eliminates operator errors and ensures consistency from test to test. To determine the baseline building pressure difference, the fan is covered with a nylon cap. After 30 seconds, the recorded baseline pressure values appear on the screen and the fan cap can be removed. Now, the measurement starts. An air flow rate is determined for each chosen building pressure difference. After finishing the series of measurements, a second baseline pressure difference is recorded. The analysis and the final results appear in the test results screen window. The standard measurement test report is then generated using the provided Excel worksheet. In addition to the depressurization test, the blower door can be used to perform a pressurization test on the building. For this technique, the fan is installed in the frame with the flow rings turned to the outside and the blue tubing is connected to the upper pressure tap on the nylon panel. During a pressurization test, air is blown into the building, which forces air to leak from the inside of the building to the outside. The versatile DG700 digital pressure gauge can also be used as a handheld instrument for testing the performance of ventilation or air conditioning systems. Using a tube allows a pressure connection to the outside. The ventilation system with heat recovery should create 0 Pascal pressure difference between the inside and the outside. This is quickly verified with the DG700. The exhaust fan flow metering box is used to measure air flows at exhaust air valves. The Minneapolis blower door makes it easy to verify draft-free buildings according to the energy saving decree and helps safeguard buildings against damage caused by uncontrolled air leaks. The blower door test stands for quality building construction and is an important part of modern energy advice. We gladly offer the opportunity for you to attend a detailed seminar in our education building where a blower door test will be demonstrated along with the latest building science information and practices.